Adrian at LOH number 8. So today is 6th of December 2023. And we have a good agenda for today. So we'll start as always with an update on the Launchpad development since last LOH. Then we will review the values interfaces that we have to remind people how everything works together, but also because we have struggled with some troubleshooting issues in the last LOH, and we have had some messages with people struggling with troubleshooting. So we'll try to address that in this session today. We've been working on schemas, which will help with auto-completion of the various values that can be passed to Launchpad namespaces and helm files. So we'll have a demo of that, and then we'll talk a bit more about troubleshooting tips in Kubernetes. This will just be a short section, but hopefully it will be useful. And then we'll move on to open discussion. All right, so since last LOH, we have had on Launchpad charts new stable releases of Eragon and Lighthouse, and those have been tested in our production and on both our testnets and mainnets. Then on Launchpad namespaces, we have released new stable releases of storage namespace, cell secrets, Postgres operator, monitoring, ingress, Gnosis, Ethereum, and Arbitrum 1. Specifically for Gnosis, we have added, we have like fully released Gnosis namespace with support for Gnosis mainnet and Chiado. And on Arbitrum 1, we have added Arbitrum 1 Sepolia support. Still working on the graph stack for Arbitrum 1 Sepolia, but the actual namespace for Arbitrum 1 is there and ready. We have also, as previously mentioned in the previous session, added issues, moving into adding, making our issues for Launchpad charts and Launchpad namespaces more public. Please, if you come across any issues, either post them there on either one of those repos or message us on the Kubernetes Launchpad, on Discord, or if you have access to Slack, if you're one of the core devs, you can also contact us on Slack. With that, thank you for posting the agenda, Billy. Carlos will go through the preview of values and the values layer. So I'm gonna hand over. Carlos, would you like me to keep on sharing my screen with the presentation?
Or I think you can do it, so I don't have to, like ask you to change slides and all of that. I think it makes more sense really quickly change that for a bit.
Okay. Over to you then.
Thank you. Which I hope is working. Can you guys see my screen? Not yet?
It works.
I can.
Okay. Okay, so as Anna said, I'm going to quickly go over a bit the structure. There's a lot of layers of packaging and it gets a bit confusing for a good reason. It's been an issue, I think, for everyone in terms of wrapping our heads around it and not making mistakes. And us included, like last LOH kind of proved. I'm going to quickly try to go over that again, review a bit. So maybe start at the bottom. We have Helm chart, right? Helm chart package Kubernetes manifest, and they accept they have a values interface where we use the values to kind of configure different parameters on the deployments we're trying to make. some of those values change actually what resources get deployed. Some of those just configure them differently for our workloads. So we have this Helm chart, which by Helm file are name releases, and they package Kubernetes resources, manifests. They are YAML manifests. And for those, you'll go to Launchpad chart. And then we have Helm files, which are another layer above. And they're what we call namespaces. And they package a bundle of Helm charts. Okay, now, so those namespaces, they pass the values down to the Helm charts, but they also accept values themselves to configure different behaviors. We'll cover those more in detail in the next slides. And we tend to organize things like on Launchpad Starter, where we have a single Helm file, which imports a bunch of namespaces that are like from Git, remote, or something like that. So we have this like main Helm file, which imports a bunch of namespaces and passes values to them. And those values, some are directed to the namespace interfaces, and some are meant to be passed down to the Helm charts, which are the releases, the different releases. As an example of Ethereum, like the releases or Helm charts will be like Aragon, Nimbus, ProxyD, and this will be the namespace, Ethereum namespace. Okay, so moving on. So let's start on the Launchpad Starter main Helm file. Well, we will have a section like this that looks a bit like this, a Helm files section, and then it's an array with a bunch of paths directing to maybe to Git namespaces from Launchpad namespaces. You can also use like a local path or even other supported URL kinds. There has been covered before, but just to structure how things flow in terms of values. This Helm file is going to end up being processed by Helm file, like the utility, the tool. And for what keywords can go into it, you can actually go look at the upstream documentation. And I can quickly show that, I think. Give me just a second. Yes, I have it here. If you go to the upstream documentation, you have like a very full coverage of every sort of parameter that you can use to tweak Helm files behavior and things like that. Going back. Now, besides importing with the different paths, we can use the values keywords on each Helm file, and you can pass a bunch of values, keywords that change something or tune how things get deployed or configured. And for that kind of interface, that includes things like target namespace, the scaling interface, the different features, flavors. Those are specific to Launchpad namespaces. And as such, you will go to the Launchpad namespace repository in terms of, just a second, I should have it here somewhere. Yes, you'll come to the repository. You have a bunch of documentation here. You'll go to the specific namespace like Ethereum. And in here, you have like what releases it has, and a bit below, you will find the values interface, which covers what features it has, flavors, and things like that. So that kind of interface will be specific to Launchpad namespaces, and those are the values that go here. In terms of how to pass down values to the Helm charts themselves, I'm going to go to the next slide. Some of the keywords you can pass here are the release names, like Aragon or Nimbus, or the Ethereum namespace. So it goes like release name, and then there's more subkeys. The values that get passed there, for each release are the ones that get sent down the line to the Helm chart. And for that interface, you will go to the Launchpad charts repository. If you go to Launchpad charts on GitHub and you open a particular chart, you go like chart, and let's go to Aragon. A bit down, you will find the whole values interface, which all the values you can use to configure. Or you will also find a values file like this one, values.yaml, which should be commented and show you all the different value keys you can pass to configure parameters. Okay, so this is kind of the structure. It gets to be a bit nested, and it gets confusing sometimes. I'm going to go to the next slide. There's like a couple of gotchas. One of those is some chart values have a top-level key with the same name as the chart. So, for instance, the Nimbus 1, you go like Helm file, we import the Ethereum namespace here, and we pass them values. And then we use the key Nimbus, because that's the name of the release. And then we say we want to pass values to Nimbus. But then the structure of values that Nimbus accepts also has a key called Nimbus, with more subkeys. So it goes like Nimbus, values, Nimbus, and more subkeys. So yes, this gets a bit confusing. It's very easy to get it wrong. And I was trying to like review why it gets to be like this, and like where you would go for different interfaces, different values. There's another note of relevance here, which is the scaling interface, which is this parameter here, like scaling, number of deployments, like 3, which is the Launchpad namespace's future. And instead of deploying a deployment or a stateful set, it replicates those and deploys independent ones, a certain number that you choose if you want to do multiple deployments like that. It names them sequentially. So if you have like 3 deployments, you'll have like a Nimbus 1, a Nimbus 2, a Nimbus 3, and you can pass different values to each one individually as you wish. And they all inherit the general Nimbus 1's values. So like this whole structure ends being a bit complex and easy to make mistakes on. And on that note, I would like to cover how we plan to address that in the future by showing off the usage of a schema on your IDE or like your preferred editor. Some of them it's an editor that supports this kind of thing, but it should. You probably use something like Visual Studio or Emacs. So Launchpad namespace is always meant to have or to make available these schemas to use. It hasn't done so yet, and I can briefly say why, but I'm just going to show off what I'm talking about first, which is having the editor being aware of the schema of the file allows you to do things like, say, we have this Helm default keyword here, and when I go to autocomplete, it gives me a list of all the properties that can go in here, and tells me this is a Boolean, and I can just put through, and now it's, yeah. It makes configuring the sorts of things or catching mistakes much easier. I'm gonna, as an example, I'm importing this namespace, Ethereum, and on this layer, what can I pass as values? And I have here like the scaling interface, or I have here like futures. And if I use autocomplete, I get to choose one of the futures. And it goes on like this. Not here, not this. Okay, so this obviously makes it much easier. Also, the releases show up here. I know I have an Aragon, a Nimbus, a proxy V. I do an Aragon, I get merge values. On this layer per release is where I could override my chart version or chart variable to show up here, or pass extra labels that I may want, or the values. So at this layer, I will be sending values to the arrogant chart, like customizing those. I didn't set up this yet, but actually this will be possible in the future as well, to incorporate here the actual values interface of each chart and have autocomplete or validation on those as well. It's also contains the general Helm file schema, like the other parameters. Like if you wanted to add releases outside of Launchpad namespaces to your Helm file, you could go like releases, gives you a boilerplate, makes it. I think it's the proper way to address this usability issue in how easy it is to make mistakes on utilizing these interfaces. So the good news is this is something we intend to do. It was planned from the start. It's not the highest priority right now, so it will take maybe a bit. But at some point, we will make this available, and it was intended to address this like that. So this was the schemas. Any thoughts or feedback on this is welcome. And on that, I'm going to pass it to Anna now for the troubleshooting while this is not available for generally yet.
Just wanted to
So yes, let me just answer Matthew. Vim obviously also supports this because both Emacs and Vim would use the same language server processor. They share that in common, so it should support it as well. Sorry, Anna, go ahead.
I was just gonna add on what you showed earlier about Nimbus as the release that is supported on Launchpad namespaces, and then you pass values, and then it's Nimbus again, which is confusing. Just wanted to clarify that the reason why we see that is because a Helm chart can install multiple components or multiple subcharts. And yeah, that's the reason why we're seeing that sometimes.
Yes, I'll quickly actually show that. I think makes it give me. I'm going to share screen again for a second, and I'm going to show the first Nimbus. Then would be the Nimbus that targets the release from the namespace. In here, I'm in Launchpad namespace repository, and the values interface. There should be a Nimbus entry, like there is here, right? And then we get to pass values to it. So you go like Nimbus values. And the format of the values that come here are the ones that come from the charts. And if I now go to Launchpad charts, and I go to the chart folder, and I find Nimbus, and I go to the values file, or the interface, but I'll just open the file because it's easier. I'll see on the format that we have like name override, image, role-based access control, and then we have an entry called Nimbus, which are things pertaining specifically to the Nimbus workload. So it's this second Nimbus that this chart has that ends up showing up as Nimbus here. You know, like inside of the values passing to the release. And that's why that repetition exists. There's all these layers. But yes, the second one you will find on this interface here, on the charts. And the first one will be coming from here, Launchpad namespaces. Okay, just wanted to connect those. Sorry, Aaron.
No, that's good. Thank you for showing that. I think that's what I was trying to say, but the visual is always better. Okay, so can you hear me better?
Yes, you seem much louder, yes.
Awesome, thank you. Before I go into some of the things I have regarding troubleshooting, and it's not that much, I just want to remind everyone again that this is a complex system in itself, like the stack of all of the things we're installing. There's a lot of dependencies, and then Kubernetes in itself is a complex system to use, and sometimes some of the knowledge and all of that comes from using it, but we are here to support people with questions or whatever comes up. So as it's been said before, please do not avoid reaching don't avoid reaching out to us. Yeah. Okay, so in terms of troubleshooting, last week on our regular LOH, 2 weeks ago actually, we came across this issue that had to do with, I think it was some workloads were pending because the PVCs weren't being created, and we tried a bunch of things, and in the end, we had a chance to look back and realize that the real issue was the indenting of values on YAML. So that is why we have gone back to do all of these schemas and just help people with that. But in terms of troubleshooting in general, just a few notes. So first of all, Launchpad Stack comes with a Helm diff plugin that is installed. And just a note here, if you are running the task releases apply and then your namespace, and you've made some changes to your Helm file, and you've saved those changes, but you do not see any diff, then that is a good indication that Helm file does not recognize the format of your changes. So here's where you would look at the values format and look at examples and stuff like that. And again, once these schemas is live and included in the stack, hopefully you won't need to do that. Another thing that I want to mention is that all of our Helm charts have been tested extensively, and what this means to you is that we have taken away the pain of having to deal with Helm linting and Helm templating to do with creating a chart. But if a chart release has failed, again, you'd install that with tasks or with Helm file directly. But if it has failed, usually a good place to look at is the Kubernetes resources, and a lot of the times you have an error that gives you an indication of what went wrong. Then in terms of other things, so we do use a variety of external Kubernetes operators in Launchpad, and those operators can be, I think finicky is the word, but some of the ones we use are Postgres operator to manage and create Postgres databases. Then we also have a Prometheus operator, or like monitoring operator, to manage Prometheus related resources, Prometheus and Alert Manager and Grafana actually. And I'm just gonna quickly because I am mentioning that one of the things you can do if a Helm release fails is to check your Kubernetes resources. Again, you can do that using the kubectl interface, but we have included K9s. And because we're mentioning operators, all of the operators install custom resource definitions. And when you search for CRDs, which is what I have here, it will show you all of the custom resource definitions created in the cluster. And then you can look at the documentation of each one of those operators for more details. But if I was to, for example, if I had an issue with the Prometheus rules that the monitoring CRD was meant to create, I could go into K9S and check Prometheus rules. I can tap this, and you would see here all of the different Prometheus rules and their status, and you can again see their YAML definition by pressing on Y, and see if your changes are match what you've updated. And you can do the same with really any resource, whether it's something that's supported by CRD or just a Kubernetes resource, whether that's a pod, a deployment, a stateful set, PVC, whatever. It can be really helpful to troubleshoot. Now, the whole concept of troubleshooting in Kubernetes is such a big, I guess it's a daunting task, and it's really hard to know exactly what to talk about and how to approach it, and it depends on what you're seeing in the cluster. So I was trying to think of how would you go about it, and I came across this website, LearnKates, that gives you a very good visual of how to troubleshoot deployments. And let me see if this actually... I'm not sure how clear this is or if I need to increase it a bit. That's not what I want. Okay, so this is quite clear. Okay, so let's say you are having an issue with a deployment resource in your cluster. You would start with kubectl get pods to see if all of your pods are running. And then if there are any pending pods, then you'd look to describe that pod. If that, depending on the events side of the pods, you can easily figure out if it's something to do with if it's a memory issue, CPU issue, so like if the cluster is full on some of its resources, and if it is, you look at provisioning a bigger cluster or just addressing that somehow. If it's not, are you hitting resource quotas and so on? Then if the pod is not pending, but the pod is not running either, so for example, it could be crashing, then you'd look at the logs, and then hopefully your application would give you some indication of what was set up wrong. If the pod is not ready, then again you would describe the pod to see why it's not ready. So for example, it could be a readiness probe failing. If a readiness probe is failing, are you passing the right path and right service port and so on? Then if you got to this point and the pod is ready indeed, but you are unable to reach out externally your application, you try to do some sort of port forwarding and try to see whether the pod is running correctly or not. This is just one visual of all of the things that you could check. And this is for a deployment. It could easily apply to a stateful set. This is just to show the scale of how of all of the things that you can come across. But usually you start from one point. If it's something to do with a pod, you start from getting pods, then describing pods, and then from there on, you should have some sort of indication. If it's a resource missing altogether, that's a bit more complicated, and it depends whether you are installing an operator or not. I can see Carlos and Chris messaging. Yes, the diagram is useful in terms of raising awareness to the many different things that may be out of the field of vision, especially if you're new to Kubernetes. But again, this is just for one issue. I will. This is all I have for now. If you have had specific errors and specific issues that you want to talk about, please let us know. And I would like to also ask Vince, how are you getting on? And if we can help, and what more resources would be helpful for us to provide to help you with your Kubernetes journey?
Well, I'll just say it's kind of been all over the place. We've been testing and breaking a lot of things and using different distributions. I'm currently playing with K0s. It actually fits more in line with the deployment scheme of our infrastructure. With K0 CTL, it makes it really easy to spin up a cluster. But I think the one thing that is, I guess, challenging is that we are not using cloud. We have finite resources. So, and those resources are going to scale dynamically depending on, if other devs deploy things within the cluster. And so we can set limit resources like Carlos mentioned. But I think the main thing is that, so how much resources we give, it seems like that will be dynamic, because if we limit the whole cluster, then we're kind of, putting a crutch on the cluster so it doesn't crash. Because basically what we were doing is overloading it completely with so many substreams that we would make it crash on purpose, but we wanted to see how it reacted to that. And it basically just went until it could, and then ran out of resources, and then all the pods crashed and everything went down. But I think the main thing is, so if we set resource limits on the pods, how do we dynamically, because there's nothing out there, at least that I found, that we can dynamically change allocating resources to different things. There are a few projects that kind of monitor those things, like Goldilocks. I did find kubectl, but a lot of them are mostly oriented towards Kubernetes, because Kubernetes is cloud oriented. So just having a difficult time trying to figure out, I guess, the Kubernetes math of limiting everything and how to dynamically change that in a limited resource environment.
Could you describe what sort of behavior you would like in practice?
Yeah, so basically we have, I guess just for a simple example, it doesn't matter if we have 1,000 CPUs or 10. The problem is that, so when we have a cluster, let's say, and we have 100 CPUs, and we allocate 60% of that to whatever we're running at the current time, and then we end up running more and more and more, and we're keeping it, below the threshold of where we crash, but then we want to add more stuff in. Now we have to change all our limits, because now it will go overboard. If we add new stuff to the cluster, it's going to say, hey, I can have this many CPUs, and eventually we will hit that wall to where we will use all resources, because we're not cloud and we can't expand indefinitely. So it's basically like, I guess, the resource limits on the pods, those have to dynamically change. to work well with a finite resource.
But that's kind of like vertical scaling, not horizontal.
Yeah.
Like I
Yes.
think ideally, the way you add more, you're covering or adding more capability will be to schedule more pods and not make the pods bigger. Like the pods will be like a fixed unit where each pod serves like
Yeah.
5 clients or whatever. And then you add more pods. You don't need to change the resource constraints because those are like tuned for 1 pod per 5 customers or something like that. You change the number of pods you have scheduled.
Yeah, but what happens when it... So are you saying I limit it to the amount of pods that would take me over to the limit? Because no matter what, if I said, I can have this many, or did horizontal scaling as well, because that's what we were doing initially, but eventually we will still hit a wall of we have no more resources.
Yes,
And we don't...
like
So are we going to have to
notice something.
change?
If you have like a pod which is designed
Yeah.
to serve a certain volume of traffic, say like 5 customers, and you say this pod can consume up to 10 CPUs and 64 gigabytes of RAM,
Sure.
and you have like 10 nodes on your cluster and you have like 1,000 CPUs or whatever, you can schedule, the cluster will schedule as many pods of those as you want until you exhaust the number of CPUs and memory you have. It won't schedule anymore. It won't crash. Like even if you ask it to schedule more pods, it will just be pending. And then you add more nodes to your cluster, and now you have more resources. And now those that were pending get scheduled.
Interesting, because initially we were using horizontal pod scaling. We didn't use vertical at all. And when we did horizontal pod scaling, we limited the CPUs and everything. And we limited it to, I think it was like 10 substreams. And we continued to run substreams. And maybe, I'd have to do it again, but because I kept amplifying more substreams, and it eventually crashed the entire cluster. And we did have what's it called, horizontal pod scaling and everything set up, but maybe, and
Yes,
it still crashed eventually.
Yeah, what must have happened there is that you had like a limit on the number of horizontal pod scaling, maybe like 10 pods max.
Yeah,
But
yeah,
each
exactly. We had 10.
each pod either didn't have limits set, resource limits like upper bounds, or the limits it set were more than 1/10 of the total resources that you wanted to devote. Because if each pod has an upper bound of a certain amount of resources, and your horizontal pod scale has like an upper bound of 10 pods or 20 pods, then like you're never going to consume more than 10 or 20 times the limits of each individual pod.
Mm-hmm.
Does that make sense? Like that threshold will never be surpassed. Like Kubernetes will, like Linux kernel will use cgrips to set those limits, and it will just kill your process if need be. But it won't go over the limit.
Yeah, because it didn't go over 10. Like it stayed at 10, and 10 was running, but then it just crashed.
I think because each pod didn't have those upper bounds set, or set to a reasonable level. Because if you have both those limits set, then if they add up, like if they're correct, compared to the resources you have available, that can't happen.
Okay, so if I have everything functioning correctly and I max it out, it should just go to a point where it's just, I have things pending and it just is kind of maxed out to what I have it set, and I shouldn't get a crash.
Yeah.
And if I over allocated, I should still get like pending.
Well, yes, one thing that I need to emphasize is you shouldn't get a crash ever at the cluster level. The pods themselves don't crash. Like if you put some workload
the
and you say
cluster was
memory
fine.
limits. Were
the cluster
the
was
pods
fine.
were the
It's
ones
all
crashing?
the pods crash. Yes, all the
Okay,
pods crash.
Okay, that's workload specific. That just means that the workload was trying to use resources above, right? There are limits.
Yeah.
And that there can't be a general solution to that because that's workload specific. Like, can the workload be constrained to handle gracefully having a limited set of resources? Or can you make it crash just because you ask more of it and you just try to allocate too much RAM and crashes or stuff like that? That's very workload specific.
Yeah, because it was a substring and that's what I was thinking as well. Because the way it kind of handled it was the cluster was fine. Like we still had Grafana and all that other good stuff running. It was just in the namespace SF Ethereum where we were running substreams. We had a max of 10. 10 were running, and then I kept adding. And I think I added like 5 or 6 substreams, and it went to 10 pods. And then I kept opening more substreams and more substreams and more substreams and more substreams. And then eventually at 25, it crashed all the pods.
Yes. So like on that, you kind of need to build logic that serves as a gatekeeper. Like the requests come from outside, right? It has to do some kind of ingress. So maybe you can like put some logic there that enforces what each backend, which will be each pod, how many like substreams it can serve, and like just starts denying more. Does like filters that to the pods. Because if the workloads don't handle that gracefully, then you need to build around it, right? You need to insert some kind of filtering at the ingress level.
So it was at the ingress level, Okay. Yeah, so basically just use something in traffic to limit the requests to X per second, something like that.
Yeah, that kind of has to be built. Maybe maybe you want to look at service meshes and proxies that you can use, and maybe have some kind of utility that makes it easier. But it is very workload specific, right? It needs to be engineered around like that.
Yeah. Okay. So that's not something traffic can handle then, as far as like limiting clients expert. Like you don't think it would handle, like if I set, I guess requests per second or something like that in a reverse proxy like traffic, because that's what we're using is metal LB in traffic. If I set something like that, I would still have the same problem.
I'm not sure. I'm not sure the request per second is exactly what you need, given that it doesn't take many requests to ask for a new substream, right? It's just like a single request, or like a few back and forth, and then you set up a new substream. Like it's not
it's a
like
ton of requests.
Yeah, and also gRPC can load multiplex connections over one socket, so you can't just look at requests per second. Unless, traffic understands gRPC message types, like internally inside the gRPC messages.
Yeah, that or Envoy, one of those probably already supports some kind of filtering or analyzing of gRPC.
Yeah, we have Envoy running with Cilium.
Yeah, but yes, it's based on that kind of tooling that you need to see if it fits what you need it to react to or filter, or you're gonna have to serve as a gatekeeper there and build something that throttles and limits, basically. You can't. You can. It's kind of like the same problem as if you're being DDoSed or something like that. Like you need to approach it as a gatekeeping kind of thing.
Okay, that makes sense.
The other related question, which I'm sure I already know the answer to, but I'll ask anyway, is so if we say we can run 10 Ethereum substream pods, great. But now we have two blockchains. We have Ethereum and Polygon. So they both have the same set of hardware they can use, but we can run like 4 Ethereum pods and 6 Polygon pods, or 10 Ethereum pods, or 10 Polygon pods, or whatever combination. So is there a way to handle that? So you can run 10 of those total, but which ones needs to be based on load? Right, and this will be more general because the graph is going to support like 100 different chains probably, and so the resource mix across which blockchain you're going to process which substreams needs to be dynamically adjusting based on a load.
The part about dynamic adjusting is going to require operators, right? Something like that.
Yeah, correct.
We were talking just about setting up something static that safe keeps that crashing thing. Like, how can you stop it? It's not very dynamic. For you to get that element of being dynamic, you need to have something that is watching a data of interest and reacting to events. So you kind of need an operator.
And in the operator, you can change the resource limits, and then it will automatically terminate a pod. Is that how it works?
Yes, you can do that.
Yeah. Okay.
It's just software that that's feeding on the event stream on Kubernetes or other data sources, because you call it as you wish. You can it's just software, right? But that is hooked up to the data stream and is authenticated to the cluster and can act also on all the resources there. So it can manage that sort of thing. But yes, like a good solution specific for substreams and all of this is not you get something you get out of the box. Like it needs to be built. Unfortunately, but it's understandable why.
Yeah, for sure, it's understandable why it needs to be built. So
yes, the role of Kubernetes here is giving you very nice APIs and a very nice framework in which to build this sort of things.
Yeah.
And but I also I'm not an expert on building these sorts of things, so I'm sure we'll exchange ideas and approaches as we go along, because eventually we also will be tackling these challenges.
Yeah, so I think that's a upcoming step for us. Okay, cool.
Also wanted to remind, so Vince, you mentioned that your Kubernetes cluster is using K0s, and I just wanted to remind you or share with you the experience we've had with K0s. I don't know if you remember, Launchpad V1 was running on K0s, and the reason why we decided to move away from it was because K0s packages all of the Kubernetes components, so the controller, API server, scheduler, into the one binary, which means sometimes you are very restricted to troubleshooting. So if something goes wrong, it's really hard to troubleshoot with all of the resources that already exist out there. So the Kubernetes community has a ridiculous amount of information of when something goes wrong with any of those Kubernetes components that make Kubernetes work. But if something goes wrong with K0s, you are limited to the project support, which we found lacking at times. Just wanted to share that with you in case you end up investing a lot of time with K0s and at some point you just come across issues and stuff like that, just so you're aware. Obviously, it's been more than a year since we used K0s, so maybe the project is a lot more mature. Yeah, just so you know.
Yeah, I did find initially installing it, if you kind of go with the base install, you can't even see your controller. But there are flags now where you can have the controller show up as a normal, like kubeadm. When you do get nodes, you can see the controller and all your controllers and everything, because those are kind of hidden in K0s. So I did find some flags that kind of expose those things and make debugging a little easier. But I just started, investigating it 2 or 3 days ago, so I haven't invested a ton of time in it. But the deployment model is something that is really attractive at the current moment for Pinax's infrastructure, anyhow.
That makes sense, and I'm glad to hear that those flags exist because it will make your life easier. Just off the top of my head, I remember there was something OpenEBS related, or just in general host path related, where if you need to share your, I think usually it's a var lib kubelet. That path is slightly different for K0s. I think it's var lib K0s kubelet. So if any of the applications you're using needs to expose that, just beware of it, or just let us know, because we might have some experience. Just let us know, or but okay, good luck. And any more questions or comments? Yeah, Payne, we're waiting for you. Okay, if there are no more questions or comments, this is all we had for you this week. Please keep on engaging. It has been really useful for us to keep on improving. We'll keep on working on the stack and making improvements on a weekly basis. And let us know if you want to see more of something specific. And as Pili said, please do fill out that form, because it will be very useful. And with that, I say goodbye, and everyone have a good day.